Good afternoon to each and everyone. I am here today to discuss to you the materials stress, strain, and failure caused by fracture. So let's start. Sa videong ito, malalaman natin ang iba't ibang properties ng materials sa pamamagitan ng kanyang stress-strain curve. Stress-strain curve. Bago pa man tayo pumunta sa subject ng Material Science and Engineering, napagdaanan na natin to sa mechanics of deformable bodies. So, atin munang pag-aralan ulit ang stress-strain curve para mas lalo natin itong maintindihan. When a body is subjected to a deforming force, may restoring force na nagde-develop which is equal to the magnitude but opposite in direction sa applied force. This restoring force per unit area is called stress, at ang deformation na nangyari ay tinatawag na strain. Ang relationship ng stress at strain ng isang material ay maaaring makita experimentally. For example, itong spring, lagyan natin ng load. Ito ay magkukos ng elongation ng spring. Kung maglalagay pa tayo ng mas malaking load, lalaki rin ang elongation. Yung elongation ay tinatawag na strain dahil sa force applied dito sa material or sa spring. Pwede nating i-plot ang force per unit area which is stress at na-produce na strain. The curve obtained help us to understand how a given material deforms with increasing loads or force. From the graph, we can see that from point O to point A, the graph is linear. Dito sa region na ito, sinusunod natin ang Hooke's law, which states that stress is directly proportional to strain. The higher the stress, the higher the strain. The body regains its original dimension if applied force is removed. This region is called elastic region. The material behaves like an elastic body. From point A to B, hindi na proportional ang stress at strain, pero maaari pang bumalik sa original dimension. Ito ay tinatawag na yield point or elastic limit. After ma-reach ang yield strength, kahit maliit ang force na in-apply, malaki ang strain na nangyayari kung mapapansin sa graph. It is represented by point B to D. Kung aalisin ang load, hindi na siya babalik sa original dimension niya or completely deform na siya. Ito rin ay tinatawag na plastic deformation. At ang point D ay tinatawag na ultimate tensile strength. Beyond this point, meron tayong final point which is the fracture point or point E. If point D at E ay close to each other, the material is said to be brittle. Examples are glass, slate, antimony, and bismuth. Kung ang point D at E ay far from each other naman, the material is said to be ductile. Examples, aluminum, copper, and steel. The stress-strain curve varies from material to material. Let's recap. The stress-strain curve varies from material to material. The stress-strain curve of a material has the following regions. Elastic region, where the body regains its original dimensions when the applied force is removed. Plastic region, where on applying a force, the body undergoes a permanent deformation. Fracture region, where additional strain is produced even by a reduced applied force and fracture occurs. In the stress-strain curve, for a brittle substance, the ultimate strength and fracture points lie close to each other. If the ultimate strength and fracture points are far from each other, the material is said to be ductile. Ngayon, malalaman natin ang stress-strain curve sa pamamagitan ng tensile test. Kaya manonood muna tayo ng video tungkol sa tensile testing.
In the first tensile test, a plain carbon steel with yield point phenomenon is to be tested. This is the test piece. It has a cylindrical test region with an original diameter of 10 mm and an original gauge length of 100 mm. Within this test region, distance marks have been drawn at regular intervals. They help to visualize and measure the plastic behavior of the specimen. Using a hand control, the tester moves the upper crosshead into its correct starting position. Now he can place the threaded ends of the test piece in the lower and upper grips of the testing machine. In the next step, he swings the extensometer into its working position and checks that everything is correctly prepared. Then he selects all necessary testing parameters on the control computer. Ready. The test starts and the extensometer's sensor arms are carefully pressed onto the test piece. This way, the gauge length can be measured throughout the whole tensile test. The gauge length is displayed at the bottom right-hand corner of the screen. At the beginning, it amounts to 100 mm.
Ito yung resulta ng ginawang tensile test kanina. Sa y-axis, makita natin yung stress or yung force per unit area. Then sa x-axis naman is yung elongation. Kung mapapansin nyo dito sa linear na graph, ito yung tinatawag na proportional limit or yung elastic region. Sa point na ito, directly proportional ang stress sa strain. At dito naman is mangyayari yung yield strength natin. Tapos, yield strength hanggang sa ultimate strength dito sa area na to, mangyayari yung strain hardening at plastic deformation. Ito yung point na hindi na siya babalik sa dati niyang sukat or dimension kung aalisin natin yung load. At dito naman sa ultimate strength, bago sa fracture point, mangyayari yung necking na tinatawag. At sa fracture point naman, dito na mapuputol yung test piece natin.
In the last step, the tester swings the extensometer back into its resting position and removes the broken test piece. On the work table, he puts the fragments back together again. With the help of the distance marks, the percentage elongation after fracture can be determined. This is the permanent strain after fracture and amounts to about 30% in this example. Please note that the percentage elongation after fracture depends on the length to diameter ratio. By measuring the smallest diameter at the point of fracture, the percentage reduction of area can be calculated. It describes the reduction of cross-sectional area at the point of fracture in relation to the original cross-sectional area.
Stress. Stress is a result from a mechanical load carried by a component. So, it is a result of any force that is acted on a material. The strength of a steel casting is the measure of its load-carrying ability. Masusukat natin ang strength ng isang bakal sa pamamagitan ng kanyang capacity na bumuhat ng mas malaking load. Elasticity. Load can be applied and removed but causes no deformation. Walang nangyayaring deformation kahit na nag-apply or nag-remove ka ng load or force sa material. Plasticity. When a large load is applied, the material will stretch and deform permanently. So sa plasticity nangyayari yung permanent deformation. Occur when yield strength is exceeded. Ultimate strength. Maximum load that can be applied before the material fractures. So ito yung maximum na force na kayang i-absorb ng ating material. What is the importance of considering these properties? So as a designer, we need to make certain that the part will not break or hindi siya magpa-permanently deform. So, kailangan nating mag-design ng casting for stress levels below the yield strength. Typically, dapat i-consider lang natin ang 50% ng yield strength ng ating material, or sa special case naman, pwedeng 2/3 or 66% as long as na-evaluate natin mabuti yung ating structural design. The strength of steel depends on composition and then the heat treatment. Steel, iron base, alloyed mainly with carbon. So ang usually na ginagamit sa construction is yung bakal na iron base at below 0.3% carbon content. The other alloying elements can add strength and important in determining the steel grade's response to heat treatment. Cooling process. Ang cooling process ay ginagamit para taasan ang kanyang ductile property. So pag nag-cooling process tayo sa isang material, bababa ang kanyang strength pero gaganda naman ang kanyang ductile property. So meron tayong iba't ibang process. First is the annealing. Annealing is the slowly cooling of the material using a furnace. Normalizing, cooling the material in still air. Normalizing is the common process na ginagamit sa construction. And then quenching. This is the rapidly cooling in water or oil. Pero pag gagamit tayo ng quenching, kailangan nating painitan muli yung ating material para hindi masyadong mababa yung strength niya. Strain. This is the amount of stretch in a loaded component. This is measured by permanent stretch in tensile test, kagaya nung kanina. Ductility, ability to stretch without cracking. So, ito yung application ng cooling process, yung ductility. Although, many designers think in terms of the material strength, most steel production is in the lower strength grades, which have good ductility. Yung carbon content and heat treatment also influence the strength and ductility. So ating kino-consider dito yung carbon content na below 0.3% dahil sa heat na nanggagaling sa ating environment and also sa welding na ginagawa sa construction. Young's modulus of elasticity. Young's modulus of elasticity is the ratio of stress and strain. The data is derived from the tensile test. Malalaman natin ang modulus sa pamamagitan ng tensile testing na ginawa rin natin kanina or pinanood natin kanina. Heat treatment does not affect this modulus. Elastic strength. This is the ability of materials to deform and return to its original form when there's adding and removing a specific load. Elastic strength. Kung aalisin natin yung force na in-apply natin, babalik pa rin siya sa kanyang original na dimension. Failure of materials by fracture. Una, brittle fracture, then ductile fracture. Brittle fracture. These are the failures occur suddenly and before plastic deformation takes place. So bago pa man pumunta sa plastic deformation, magkakaroon na ng brittle fracture. Generally occurs in materials with weakest atomic bonding such as glass and concrete. Ductile fracture takes place at some stress above the yield point. Usually seen in tensile tests. So for safety purposes, dapat yung working stress natin ay hindi mag-exceed ng 50% doon sa kanyang yield point. So, thank you for listening and have a good day.